Hello again, my dear students. Now we will continue part 3. The question said, after breaking a leg, a girl was given a crutches. The free body diagram for the girl when standing with the crutches is shown, and it is not to scale, you can't measure it. Okay, so we have F1 or F2 and weight. Half of the girl's weight W is supported by the reaction force. So the first part you have to know R equal half weight of the girl. Okay, the reaction force R of the ground on her leg. Half of her weight is supported by F1 and F2. So it means F1 plus F2 is the rest, half weight also. The forces of the crutches on her body. F1, F2 are at the same angle, so it means same angle with the vertical, so it means this angle equal this angle. So angle is equal theta 1 equal theta 2. Show that the magnitude of F1 and F2 are equal. So we have to show that F1 equal F2. So what should we do now? First, you have to put the horizontal and the vertical. Okay, so as you see, at horizontal we have F1 and F2 can be resolved to a vertical component and a horizontal component. Okay, so now we have F2x and F1x, and because a girl is horizontally in equilibrium, it means what? Resultant horizontal force equals 0. So I will start with resultant horizontal force equal what? 0. What it means? It means F2x and F1x are equal. And what is F1 equal? So I will write F1x equal F2x. So F1 is because the angle with the vertical here. So F1 is F1x is F1 sine theta. It means F1 sine theta equal F2 sine theta. Okay, theta 1 and theta 2. And because theta 1 equal theta 2, it means sine theta 1 equal sine theta 2. So this means what? F1 equal F2. Now we gain 2 marks. I'm trying to explain all these steps to make you to make sure you understand my answer. Okay. Now he said calculate the magnitude of F1, and he gave me the weight and angle of F1 equal 10. So now we will move again. I can draw the forces affect the girl. We have weight, which equal 650 Newton, and we have R, which equal half weight, and we have two forces, F2 and F1. So now we will talk about vertical component. Okay, so we will say what? We'll start with vertical component, vertical resultant force also equals 0. What it means? It means upward force equal downward force. So R plus F1y plus F2y equal weight. Okay, and because we know is R is half weight, so F1y plus f2y equal half weight. What is f1y and f2y? f1y because the angle with y, theta, yes, so we can write because f1 equal f2 from the last part, so we can write equal f. So f cosine theta plus f cosine theta equal half weight. This is means 2f cosine 10 equal half multiply weight is 650. It means f equal the half of 650 is 3. So I have to use my calculator. $325 divided by 2 cosine 10 equal what? So it equal 165 Newton. So the answer is 165 Newton. Let's move to the next. The diagram below shows the forces acting on one of the crutches. The crutch is at an angle theta. Yes. To the vertical, the weight of the crutch has been ignored. Reaction force, we have reaction force from the ground, okay, and we have frictional force of the ground on the crutch, okay, and we have force exerted by the body on the crutch. Okay, now there is a maximum frictional force that the ground can exert on the crutch. Explain what will happen if the girl move the base of the crutch too far from her foot. So first you have to resolve the force exerted by body on the crutch. So again I will draw the horizontal. Okay, it will be like this. For example, this is the horizontal, and I will resolve the force of the girl. Okay, so now I can write it as Fx and Fy. Okay, and as you see, to become in equilibrium, so frictional force must equal Fx, which is F sine theta. So I will start with friction force, frictional force equal F sine theta. Okay, and he said what will happen if the gauge moves the base on the crutch too far? It means like this. So now if it move it too far, angle will increase. So as angle theta increase, what happened? Sine theta also increase. So frictional force increases. Okay, so this will be the answer for this part. Now we have question 12. A boat heads across a river toward X. So this boat moving toward X at speed of 1.1. As shown, the speed of the river from west to east is, so this is the speed of river. Okay, now the boat reaches the South River bank at Y. It means the boat, instead of moving in a straight line, okay, due to the river velocity or river speed, it moves in this direction. Okay, okay. Now determine the distance xy. He asked about this distance xy. Width of river is 75 meter. Okay, now first we can find this angle theta using what? Using the vertical speed and horizontal speed. So we will use tan theta equal opposite, which is V rever, over the adjacent is V vertical, okay, of the boat يعني. So it will be 0.55 divided by 1.1. And also, because xy is a distance, okay, and we have this distance vertical, so we have also horizontal and vertical, so we can use the same equation. Tan theta equal opposite is xy over 75. Now because we are talking about the same angle, we can write 0.55 over 1.1 equal xy over 75. Now we will use a cross multiplication, so xy will equal 75 multiply 0.55 over 1.1. So now we have to use calculator. Xy will equal 37.5, and we have to use the same unit for, so it will be meter. Okay, we can round it because we are talking about only two significant figures, so we have to round it to 38 meter, and don't forget to use same significant figure. Okay, now let's move to the next. A ball bearing moves across a horizontal bench towards a magnet as shown. We have ball bearing attracted to a magnet. Okay, the velocity time graph for the horizontal motion of the ball bearing up to the point of contact with the magnet is shown. So he mean the graph talking about velocity from this point until reach to the magnet. Okay, explain the shape of the graph. So as you see, first, what happened to the speed? The speed decreased until this point. Then the speed start to increase. We have acceleration here until reach to the maximum velocity. So if you want to explain the shape, you have to explain what happened to the velocity. And because we have a different action, so we have to make it out, to explain it in what? In term of time. So I will write between t equals 0 and t equal 0.3 second, because time here in second. Okay, so what happened? The velocity decrease. Okay, and if you want to explain why, of course the only affect the ball, okay, is friction, because friction force opposite motion always. So we can write because friction force greater than attraction force. Okay, so resultant force against motion. Okay, opposite motion. Okay, now what about the second part? From time equals 0.3 to, what is the last time? We are talking about 0.64. So until to 0.64 second. What happened now? The speed increase. So it will be because as the ball become closer to the magnet, the attraction force becomes greater. This is the explanation of the ship and the reason for each action. Okay. Now calculate the maximum acceleration of the ball bearing. Because we have velocity time graph, so acceleration must be equal gradient of the line. And if you want to find the maximum acceleration, we have a curve, not straight line, so we have to draw our straight line. So we have to draw tangent. So I will start my answer with writing acceleration equal gradient of the line. Now I will find the gradient equal V2 minus V1 over T2 minus T1. This is how to find the gradient. Now I will choose 2 points as far as possible on the tangent which I draw. So I have this point. So this will be T1, which equal 0.48, and we have T2, which is equal what? T2 equal 0.64, and also we have V1 equal 0 and V2 is here, so V2 equal 0.48. So now we have to calculate 0.48 minus 0, 0.48 minus 0, V2 minus V1 over T2 minus T1. T2 is 0.64, 0.64 minus 0.48. So it will equal 2.88, and the unit is meter second minus 2. We have to look about how many significant figure we have. We have 2 significant figure, in fact, so we have to write it as, it will be 2.9 meter second minus 2. This is the maximum acceleration. Now let's move to the next question, question 14. The toughness of a sample of a material can be measured using an ISOT impact test. The diagram shows the ISOT impact tester. A sample of the material is placed in the tester as shown. A pivoted hammer, so we have a pivoted hammer here, of mass m is released from a height h, so this is the initial height, and strike the sample. The sample breaks, okay, the height h to which the hammer ray rises after the impact is measured, so we have final height is measured. Okay, now name the point at which on the hammer to which the height h and h are measured. Of course, every time we will measure the height, it will be measured until center of mass or center of gravity, so it will be center of gravity or center of mass. Both are correct. Okay. Also, he said state an equation for the energy transfer to sample. So as you know, the energy transfer to sample is the change in gravitational potential energy. So we will write a change in gravitational potential energy, which equal m multiply g multiply change in height, which is h minus h. Okay, so this is the magnitude of the change in energy which is transferred to the impact. Okay, now let's move to the next. In a game of cricket, a player hits the ball which takes path B. Yes. Air resistance acted on the ball as traveled through the air. If there was no air resistance, the ball would have followed path Q. Draw a free body force diagram for the ball. when at the position marked X on the path B. Okay, and okay, if marked X, so we have in this position we have to draw the force because we have a resistance. So of course we have, this is weight, and of course we have a resistance in opposite direction. So I will draw like this. So it will be weight downward, must start from the point. Okay, and we will draw a resistance. Okay, so this will be, and we have to label it. So I will write weight and a resistance. Okay, now explain the difference between path B and path Q. What is the difference between path B and path Q? Of course, we have difference in range. Range of B is smaller than range of Q. And also we have different maximum height. Maximum height of Q is greater than H max, greater than maximum height of P. So we have to explain each one. To know what is the difference, we have to explain in terms of forces, because we have a resistance in path B and we don't have a resistance in path Q. Okay, so to start with the horizontal forces, okay, so I have to show you what happens if we have a resistance and if we don't have a resistance. So for example, if we don't have resistance, this will be so as you see, we have a single force affect the ball, which is what? Gravitational force. Yes, this is a gravitational force, and this is a vertical downward only. We don't have any horizontal force. Okay, so it will continue, and this is a constant force downward, which is weight. Now, what will happen if we have a resistance? Okay, as you see, I have to release it again. Okay, and I will make it again because by mistake I press for 2, but I need only 1. Okay, so this is the first one. Only one force affect the ball, and now we will talk about the second one. So as you see, we have drag force downwards and also drag force horizontally. So as you see, we have drag force. Okay, and also it can be more. I can show it to be more clear. Okay, so I can press this angle. Now as you see, we have a horizontal drag force which makes the horizontal velocity less, so it will decrease the horizontal velocity. This is why it will reach to a less horizontal distance. And also as you see, we have a drag force downward which make a more deceleration, so it means we have a less vertical velocity. This is why it will reach to a lower height. As you see, we have a drag force horizontal and vertical. Okay, well, now without a resistance, it will have a higher range and a higher maximum height. Okay, so this is what we will explain, or what will we write. Okay, now let's start. Explain the difference between path B. So I will write path B has a lower range because the horizontal air resistance force will decrease the horizontal velocity. Okay, and also path B has a lower height because the vertical component of air resistance will increase the downward force, the resultant downward force, force. So it will decrease it will decrease, or it will increase the deceleration, because we have it increase resultant downward force, so it will increase the deceleration. Okay, this is why we have a lower maximum height. Okay, now let's move to the next. The ball was given an initial velocity, so we have initial velocity equal 35 with an angle equal 25. So the first thing you have to write ux and uy. Ux is u cosine theta and uy is u sine theta, because the angle with the horizontal. Okay, so it will be 35 cosine 25 and 35 sine 25. So I will find both using my calculator. So we have the horizontal component equal 31.7 meter second minus 1, and what about the vertical? The vertical is 14.8 meter second minus 1. Okay, now let's continue. He said the horizontal distance from the player to boundary is 85. So the horizontal distance means range equal the horizontal distance, you can write it as 85, okay, as range. The player scores 6 runs if the ball lands beyond the boundary. It means if the ball lands after this value, 85. Okay, determine whether 6 runs will be scored, ignore the effect of a resistance. So what it means we have to find the range or the horizontal distance moved. If it's greater than or equal 85, now we have a record. Okay, the player will record a goal. Okay, so first I will start with Sx, which is equal Ux multiply time, but we don't have time. So if you have to find time first, using this equation, Vy equal Uy plus or minus, because we are moving up. So moving up, it will decelerate. So now Vy at the maximum height equals 0. So this is time for maximum height. Okay, 0 at maximum height, Vy equals 0, and we find Uy, which is 14.8 minus 9.81 multiply time. So now time equal 14.8 over 9.81, which equal what? Which equal 1.508. 1.508. And when the ball land, it will take 2 times. So now time for the total travel to land, it will be 2 multiply 1.508. So it will equal, I have to use my calculator, 1.506 multiply 2, which equal 3.012. 3.012 seconds. Now I will move to this equation to complete my answer. It will be ux, which is equal 31.7 multiply 3.012. So now SX horizontal distance moved will be, I have to use my calculator again, multiply 31.7 equal, it will be 95.5 meter. So 6 runs will be scored. So 6 runs will be scored. This is how to solve this question, okay? Now a student state Newton's first law of motion as, if there is no external force, there will be no motion. Of course this is correct. Try this statement. I will start with, if no external force, we can't use is no external force. So first, student must replace no external force with no resultant force. And replace no motion, because maybe the object is moving but with a constant speed. And also no motion must be replaced with no acceleration or no change in velocity. This is what the students must replace. Okay. Now let's move to the next part B. Okay. The diagram shows a person pushing a trolley and pulling a trolley. The angle theta between the arms of the person and the horizontal is the same for both pushing and pulling. Corresponding diagram show the forces on the trolley for pushing and pulling are also shown. So as you see, pushing and pulling, normal contact force in both, and we have weight in both, and friction in both. But what is the difference? We have a force of a person here, Fm, and a force of a person here is with this angle up, and this is 2 down. So now, of course, my explanation will be on the drawing. So he said it can be assumed that the frictional force between the trolley and the ground is proportional to the normal contact force of the ground on the trolley. Explain why pulling the trolley a certain distance requires the person to do less work than pushing the trolley the same distance. First, you have to be sure what the type of work the student must, or the person must do. The force against friction, because the person will move the trolley horizontally. and the only force acts in the horizontal level is what? Frictional force. Okay, so as you see, you can explain in terms of the first figure or second figure. I will try to solve it using what? The second one. Okay, now this is the force of person, which is can be resolved to a vertical component and also to what? A vertical component. So we have Fmx and Fm what? Y. Okay, so now what about Fy? When Fy exert, what happened to the normal force? Before Fy, normal force are equal weight. Okay, because the trolley in a horizontal equilibrium, it doesn't move up or down. Okay, now after the force of the person, we have a vertical component of F, so now we have two forces up. Now after that, in the second case, we have R plus Fy equal weight. What it means? It means R will be less. And as R become less, what happened? The friction force will become less. The friction force, because the friction force become less. This will be what will happen. Yeah. If friction force become less, now we need a lower force, or we need to do a lower work against the friction. This is my explanation. Okay, so now we have to arrange our answers. Okay, I will start with pulling. So I will start with pulling will give an upward force, will give an upward force, which is what? The vertical component F dash M Y. Okay, and this will do what? Now, so normal reaction force or normal contact force will decrease. Okay, and so what happened when normal contact force will decrease? So the frictional force also will decrease. Okay, and what happened also if frictional force decrease? Now we will write work equal friction force multiply distance, which mean work done against friction force will decrease. This is why I explain why pulling the trolley a certain distance require person to do less work needed. So now we have less work needed to push the trolley. Okay, how to move the trolley. Now the next question 19. An underwater system for detecting earthquakes is placed on the seabed. The system includes a pressure sensor and 10 glass spheres. The system is connected to a data hub. Okay, anchor. Regular signals are sent via satellite to a central control station. Okay, now as you see, this is the system. The system and anchor are released just below the surface of water. they accelerate first for a few seconds and then fall to seabed as a constant velocity. Calculate the initial acceleration for the system and anchor. Of course, if you want to find acceleration, you have to use F net equal mass multiply acceleration. This question has 3 marks. So first you have to find what is F net. Okay, I will consider this is the system. So we have the first force is weight. Okay, and what about the second force? Because the system is moving in water, so we have also upward force, which is equal upthrust force. So now to find F net, you have to subtract the greater force, which is weight, because system moving down, minus upthrust force, U. So it will equal, first, what is the weight of the system? Weight of the system is mg of system minus U is given, because he gave us the upthrust force. So it will equal 470, it's a mass, multiply 9.81 minus 2500. I have to use my calculator. Now we have 2010, 110.7 Newton. Now to find the acceleration, you have to make rearrange, so it will be equal F net over mass. So 2110.7 over mass, which is 470, so it will be 4.5 meter second minus 2. I have to write the answer here, 4.5 meter second minus 2. Now explain why after a few seconds the system and anchor fall to seabed at a constant velocity. So as you know, this is like a skydiver falling in air resistance. As speed increase, air resistance increase, and until become balanced with weight. But instead of air resistance, we have a drag force of liquid. So I will write as speed increase, the drag force increase until balance the weight and resultant force becomes 0 and acceleration equals 0. So system is falling now with constant velocity, which is called the terminal velocity. Okay, calculate the drag force acting on the system and anchor as they fall at a constant velocity. So now we have resultant force must equal 0. So now how we can find the drag force? I will write drag force equal weight minus upthrust. We find it 2110.7. so it will be for how many significant figure we have? I can write it as 2110 Newton. Okay, state what's meant by gravitational field strength, G. We are talking about what is the definition of gravitational field strength. Okay, so now it's the force per unit mass. The gravitational force per unit mass. Okay, also he asked to find the definition of center of gravity, a point at which the weight of an object is considered to act. And the last part is the gravitational field strength G equal 9.81 show that the result acceleration of free fall equal 9.8. So first we have to write F net equal mass multiply acceleration, and because we have an object is falling for free fall means no drag force. So we have the only force act here is weight equal ma, and because weight equal mg, so mg equal ma, we can cancel mass from both terms, so g equal a. This is why acceleration equal 9.81. Okay, so now we have finished this part. See you in the last part soon.